Here's a nice straightforward question in two parts. Firstly, we need to find the gradient of the line through A and B. Now, remembering our gradient formula, which is the gradient is equal to the difference between the y coordinates divided by the difference between the x coordinates. So that gives us the gradient of AB is going to be minus 2 minus 4 over 1 minus minus 3, which is negative 6 over 4, or that's just minus 3 over 2. Now we can find the equation of the line AB. Now here we need to use our point gradient form. So in other words, y minus the y coordinate of one of the points on the line is equal to the gradient times x minus the x coordinate of that point. So here we're just going to use point A. So y minus minus 2 is equal to minus 3 over 2 brackets x minus 1. Notice again that we're just using this point for x and y. We're just going to clean that up a bit. So we have y plus 2 equals minus 3 over 2 brackets x minus 1. We want the general form, so let's just get rid of this denominator by multiplying everything by 2. So we get 2y plus 4 equals minus 3 brackets x minus 1. We hate fractions, but now they've disappeared. We can now expand, so 2y plus 4 equals minus 3x plus 3. And let's move everything over to this side so the x is positive. So we get 3x plus 2y plus 1 is equal to 0. Now, the second part of this question is asking us to find the line through A and perpendicular to AB. Now, the gradient perpendicular to AB is going to be the negative reciprocal. So the gradient is going to be positive 2 over 3. Okay? The old gradient was negative, so the new gradient is going to be positive. And we flip the fraction around because it's reciprocal. Okay? Remember, two gradients have to multiply to make negative 1 for them to be perpendicular. Next, we use our point gradient form. And it's through A, so we can use point A again. So we get y minus minus 2 equals 2/3 brackets x minus 1. We clean that up a bit to make y plus 2. We get rid of that fraction by multiplying everything by 3. So we get 3y plus 6 equals 2 brackets x minus 1. We expand, so we get 2x minus 2, and because x is positive, we'll move everything over to that side, and our final equation is 2x minus 3y minus 8 is equal to 0. And we're done. Here's a good question that is just going to test our simultaneous equation skills. Remember, 3 lines are concurrent if the point of intersection of 2 of the lines lies on the third line. So, in this example, we have to find the point of intersection of L1 and L2. So, we have x plus y equals 2, 4x minus y equals 13. We can solve by elimination here. We call this equation A, equation B. So if we add A and B, we get 5x equals 15, which means x equals 3. Sub that into A, we get 3 plus y equals 2, y equals negative 1. So m is the point, 3 minus 1. Now, to test whether m lies on L3, we just have to substitute in. So 2 brackets 3 minus 5 brackets minus 1 equals 11. In other words, 6 plus 5 equals 11, which is a true statement. Therefore, because m lies in L3 and it's the point of intersection of L1 and 2, they are all concurrent. Now we just want to use the same method to test second pair of lines. So let's just do this whole process again. We will take second two equations because we have the same x coordinate. So we have x plus 3y equals 15 and x minus 2y equals minus 18. Okay, let's call this equation A and equation B. If we subtract B from A, the x's disappear. 3 minus minus 2 is 5y. 15 minus minus 18 is 33. Therefore we have y is 6 3/5. Now let's substitute that back into one of the equations. A is as good as any. So we have x plus 3 brackets 6 3/5 equals 15, which means x plus 18, 19 4/5 equals 15, which means x equals minus 4 4/5. Okay, so our point is minus 4 4/5, 6 3/5. Not a nice set of numbers. Now to work out whether the three lines are concurrent, we need to substitute that back into the third equation, which is 2x plus y equals minus 1. So 2 brackets minus 4 4/5 plus 6 3/5 is equal to minus 1. Well, let's see, that's minus 9 3/5 plus 6 3/5, which is not what we want. No, that equals minus 3. So, therefore, the points are not concurrent. Excellent. So, we might just double check that, make sure I did the maths right. But in short, you solve two of the equations, substitute into the third equation. If it satisfies the third equation, then they're concurrent, otherwise they are not concurrent.